Hey everyone, generative AI. It's like it's suddenly everywhere, right? It feels like it just exploded, and now it's in our apps and it's all over the news. It's even changing how some jobs work.
Yeah.
So, we are going to do a deep dive into all of this. We're going to cut through all the hype and really try to give you a clear and concise understanding of what generative AI is, how it works,
Right.
what its potential benefits and risks are, and why it matters to you.
And the timing of this is really key because the reason it feels so sudden is because a few breakthroughs happened really recently. But to understand how generative AI works, we actually need to go back a bit further to what AI used to be like.
Yeah, that's a good point. Like, I get that AI was already being used for things like, spotting credit card fraud or like recommending songs on Spotify,
Right.
but that's not really creating things, is it?
Exactly. The older AI was mostly about making predictions based on patterns and data. It's like if you gave it a million photos of cats and dogs, it could then look at a new photo and say, okay, that's probably a dog.
Right.
Generative AI, on the other hand, could take all those cat and dog photos and then generate an image of a cat-dog hybrid.
Whoa.
That doesn't even exist in real life.
Okay, that's where things get really interesting. So it's not just about analyzing what's already there, but it's actually creating something new. Is it actually creative, though, in the way that humans are?
It's not creativity like how we experience it, no,
Right.
but the results can definitely feel that way. At its core, generative AI relies on something called deep learning, which uses artificial neural networks.
Okay.
These networks are modeled after the human brain,
Mm-hmm.
but instead of neurons, they have these interconnected nodes that process information, and these networks learn by analyzing huge amounts of data, finding patterns,
Right.
and then using those patterns to
Wow.
generate brand new content.
So it's kind of like giving the AI a crash course in like catness or dogness by showing it tons of examples and then letting it come up with its own version.
That's a great way to put it.
Oh,
And there are different types of models that excel at different things, like creating images versus writing text.
right.
A model that is trained on images would be useless for composing music.
Okay, so it's not like there's one generative AI that does it all. There are different models with different strengths. What are some of the most common types of models out there?
Let's start with generative adversarial networks, or GANs for short.
Okay.
This is a really clever setup where you actually have two neural networks working against each other.
Okay.
So one is the generator, which tries to create content like an image or some text,
Mm-hmm.
and the other is called the discriminator, which tries to tell if the content is real or fake.
So it's like a constant competition.
Exactly.
One's trying to fool the other into thinking its creation is the real deal.
Yes, and through this back and forth, the generator actually gets better and better at producing realistic content.
Wow.
GANs have been really successful, especially in creating images and videos like those incredibly realistic deepfakes you might have seen.
Yeah, I've seen some of those, and they are pretty mind-blowing, even if they're a bit unnerving sometimes.
Right.
So GANs are the go-to for visuals. But what about text? We know that AI can right now, thanks to things like ChatGPT.
Yeah, for text, the real game changer has been a model architecture called transformers.
Okay.
It's revolutionized natural language processing, and it allows AI to understand and generate text in a much more sophisticated way.
So is that how ChatGPT can hold a conversation or write a poem that sounds almost human?
Yes, and this is where things get a little more technical. Transformers rely on a few key concepts: tokenization, embedding self-attention,
Okay.
and feed-forward networks.
Okay, break those down for me. I know a little bit about AI, but those are new terms.
Imagine you're teaching an AI about a sentence like, "the cat sat on the mat." Tokenization would be breaking that sentence down into individual units like the cat
Right.
sat on and so on.
Got it.
Embedding is about converting those tokens into numerical representations that the AI can actually understand.
So it's like translating human language into the language of math that the AI can process.
Precisely. Now, self-attention is where things get really interesting.
Huh?
It allows the AI to analyze relationships between different words in a sentence,
Oh, wow.
understanding context and meaning. For example, it helps the AI realize that cat is the subject of the sentence and mat is the object.
So the AI is not just seeing a bunch of words, it's actually figuring out how they relate to each other, just like we do when we read.
Exactly. And finally, we have the feed-forward network, which takes all of this information,
Okay.
the tokens, the embeddings, the context, from self-attention,
Right.
and it uses it to generate new text, word by word, ensuring that it makes sense and it follows grammatical rules.
Wow, that's pretty complex.
It is.
But it's amazing how it all comes together to make something that seems so simple, like a chatbot possible.
It is, and we've only just scratched the surface of transformer models.
Wow.
They're being used for all sorts of things, from translating languages to writing code to summarizing complex information.
Okay, so we've got Jans for visuals and transformers for text. Are there any other major players in the generative AI world? What about like music or creating realistic virtual worlds?
There are two other model types that are really crucial here.
Yeah.
First up, variational autoencoders, or VAEs.
Okay.
Imagine you're trying to teach an AI about faces.
Okay.
A VAE wouldn't just memorize every single face it sees. Instead, it would learn the essential features that make a face,
Right.
like the eyes, the nose, the mouth,
Yeah.
their relative positions.
So it's like learning the blueprint of a face, not just copying individual examples.
Exactly. And once it has that blueprint, you can then generate new, unique faces that have never existed before, all while keeping the essential characteristics of a face.
It's a bit like how we might draw a face. We don't copy a specific person exactly, but we know what features need to be there and how they generally fit together.
That's a great analogy. VAEs are great for generating variations on a theme, creating things that are similar to what they've been trained on, but still unique.
And what about the virtual worlds part? I know some games are using AI to generate environments, and that must be like a whole other level of complexity.
That's where diffusion models come in. These have become incredibly popular lately, especially for generating high-quality images.
Okay.
They work by starting with random noise. Imagine like a static TV screen.
Okay.
And then they gradually refine that noise step by step until it forms a coherent image.
So it's like taking a completely chaotic jumble of pixels and slowly molding it into a recognizable picture.
Yeah, that's a great way to visualize it.
Wow.
And the amazing thing is that diffusion models can create incredibly detailed and realistic images, often surpassing the quality of images generated by GANs.
Wow, it seems like there's a whole family of generative AI models out there, each with its own specialty. It's mind-boggling to think about how far this technology has come in such a short time. But I think it's time we shift gears a bit. Now that we've got a grasp on the basics, let's talk about how generative AI is actually being used today.
Absolutely. Let's dive into the real-world applications and see how this technology is changing the game across various fields.
You know, we've been talking a lot about the technical side of things, but I'm really curious to see how generative AI is actually being used out in the wild. You know, it's one thing to understand the concept, but it's another to see it in action.
And the range of applications is truly vast. It's touching everything from creative arts to scientific research, and even to seemingly mundane tasks like writing emails.
Right.
Let's start with something that many people are probably already familiar with, the text generation.
Yeah, I think chatbots like ChatGPT have really brought AI writing into the mainstream. Suddenly, everyone's playing around with AI to write poems or scripts or even just get help with their emails.
ChatGPT is definitely a poster child for generative AI, but it's just the tip of the iceberg. There are AI-powered writing assistants that can help you refine your grammar, your style, your tone. They can even adapt to different writing styles, whether you need a formal report or a casual blog post.
So it's not just about generating creative text, it's also about making us better writers ourselves.
Exactly. And think about the implications for things like translation. We're already seeing AI tools that can translate languages with incredible accuracy and fluency, breaking down communication barriers like never before.
That's huge, especially in a world that's becoming increasingly interconnected. Imagine being able to understand and communicate with people from all over the globe, regardless of language differences.
And for those who work with code, there are tools like GitHub Copilot that can suggest code completions, generate entire functions, and even help you debug your code. It's like having a pair programmer right there in your IDE, making you a more efficient and effective coder.
It sounds like generative AI is not just changing how we write, but how we work with language in general. It's almost like giving us a superpower to communicate and create more effectively.
And that's just the tech side of things. Let's move on to images, where generative AI is making equally impressive strides. Tools like DALL-E Midjourney and Stable Diffusion have really captured the public's imagination with their ability to create stunning original images from simple text descriptions.
I've played around with those tools a bit, and it really does feel like magic. You type in a phrase like, a cat riding a unicorn through a field of rainbows, and boom, the AI generates an image that's both fantastical and strangely believable.
It's a testament to the power of these models to understand and translate abstract concepts into visual form. And it's not just about creating whimsical images.
Hmm.
Generative AI is being used to enhance image resolution, create photorealistic avatars for games and virtual worlds, and even generate video content.
I saw a demo of Google's new Sora model, and it's mind-blowing. It can create a video up to a minute long with complex scenes, multiple characters, and incredible detail. It's almost indistinguishable from a real video.
And this is where the different types of generative AI models we discussed earlier come into play. DANs are often used for video and image generation due to their ability to create realistic visuals, while transformer models excel at text generation. Each model has its own strengths and is better suited for specific tasks.
It's like having a toolbox full of specialized AI tools, each designed to tackle a different creative challenge. And it's not just about visual and textual content. What about things like music and audio? Can AI create in those realms as well?
Absolutely. There are AI tools that can compose music in various styles, generate sound effects, and even synthesize realistic human speech. Imagine being able to create custom soundtracks for your videos, generate unique sound effects for your games, or even have an AI assistant that reads your emails to you in a natural-sounding voice.
I've experimented with some AI music generators, and it's incredible how they can capture the nuances of different genres and create original pieces that are both catchy and complex. It's really pushing the boundaries of what's possible in music creation.
And tools like Amazon Polly and DeepMind are doing amazing things with speech synthesis, making it sound incredibly natural and expressive.
Okay.
It's hard to tell the difference between an AI-generated voice and a human voice these days.
It seems like generative AI is becoming this incredible creative partner, helping us generate ideas, explore new possibilities, and bring our visions to life in ways we never thought possible. But beyond these creative applications, I'm curious to know how generative AI is being used in more practical or even scientific fields.
That's a great point. Generative AI isn't just about art and entertainment. It's also a powerful tool for research development and problem solving. For example, it's being used to create synthetic data, which is essential for training other AI models, especially in situations where real-world data is scarce or sensitive.
So instead of relying solely on real-world data, which can be expensive or difficult to obtain, we can use AI to generate artificial data that's just as good for training purposes.
Exactly. This is a game changer for fields like robotics, self-driving cars, and medical research. For example, imagine training a self-driving car, AI, on real-world traffic scenarios. It would be incredibly dangerous and time-consuming to expose a real car to all those situations. But with synthetic data, you can create a virtual world where the AI can learn and experiment safely without any risk to humans.
That makes a lot of sense. And in medical research, I imagine synthetic data could be used to simulate the effects of new drugs or treatments without having to conduct risky or expensive clinical trials on real patients.
Precisely. And it goes beyond just simulating data. Generative AI is being used to design new drugs, discover new materials, and even model complex systems like climate change.
It's like giving scientists a new set of eyes to see patterns and possibilities that were previously hidden from view.
It's really opening up new frontiers in scientific discovery and technological innovation. But as we delve deeper into the applications of generative AI, it's important to acknowledge that this technology is not without its limitations and potential downsides.
That's a crucial point. While we've been focusing on the exciting possibilities, we need to be mindful of the potential risks and challenges that come with such a powerful tool. Let's explore those aspects in more detail. Thinking about all this, it really hits me that generative AI isn't just like another tech trend. It feels like a fundamental shift. Almost like the invention of the internet, but for creation itself.
That's a great comparison. The internet changed how we access and share information, and generative AI has that same potential, but for how we create information, whether that's, text images, music, even scientific discoveries.
It's like we're democratizing creativity in a way, giving more people the tools to express themselves and bring their ideas to life, even if they don't have, traditional artistic skills or technical expertise.
Exactly. Someone who can't draw could still describe their vision to an AI and see it translated into a stunning image. Or someone with a melody in their head but no musical training could have an AI help them compose a full song.
And it's not just about individual expression. Think about how generative AI could change fields like education or research. Imagine personalized learning experiences tailored to each student's needs, or AI tools that help scientists analyze massive data sets and uncover breakthroughs faster.
Those are just a few examples of how generative AI could be a force for good, empowering us to solve complex problems, advance knowledge, and create a better future. But as we've discussed, there are also potential downsides that we need to be mindful of.
The misuse, the bias, the potential job displacement, those are serious concerns that we can't just brush aside. It feels like we're at a crossroads and we need to be very intentional about the path we choose.
I agree. We need to approach generative AI with a balance of optimism and caution. Optimism about its potential to improve our lives and solve some of the world's biggest challenges, but also caution to ensure that it's developed and used responsibly, ethically, and in a way that benefits all of humanity, not just a select few.
That brings up an interesting point. We've talked a lot about the technical aspects of generative AI, but ultimately its impact will depend on how we choose to use it. It's a tool, and like any tool, it can be used for good or for ill.
And that's where the human element comes in. We need to have these open and honest conversations about the ethical implications of generative AI, the potential risks and benefits, and how we can ensure that it's used in a way that aligns with our values and aspirations.
It feels like we're having those conversations right now, not just on this deep dive, but all over the world. People are starting to really grapple with what it means to live in a world where machines can create, and they're demanding that we consider the societal and ethical consequences.
And that's a positive sign. We need to engage in this global dialogue about AI, involving not just technologists and policymakers, but also artists, ethicists, educators, everyday citizens. The future of AI is not something that should be decided by a select few. It's something that we need to shape together as a society.
So what does that look like in practice? How do we ensure that generative AI is used for good and that its benefits are shared widely?
There are many steps we can take. First, we need to invest in AI education and literacy, helping people understand how this technology works, its potential impact, and how to use it safely and responsibly. We also need to establish clear ethical guidelines and regulations for AI development and deployment, ensuring that it's used in a way that protects human rights, promotes fairness, and minimizes harm.
And we need to be mindful of the potential impact on jobs and the economy, providing support for workers who might be displaced by automation and creating opportunities for people to reskill and adapt to the changing job market.
It's also important to foster a culture of transparency and accountability around AI, making sure that algorithms are explainable, that data is used responsibly, and that there are mechanisms for addressing bias and discrimination.
It sounds like we're talking about a fundamental shift in our relationship with technology. It's not just about creating cool gadgets anymore. It's about creating a future where technology empowers us, enhances our lives, and helps us build a more just and sustainable world.
And that's a future worth striving for. Generative AI, for all its complexities and challenges, presents us with this incredible opportunity to reshape our world for the better. But it's up to us to make sure we seize that opportunity wisely, thoughtfully, and with a deep sense of responsibility.
This deep dive has been a real eye-opener for me, and I hope it has been for you too, listener. We've only scratched the surface of this vast and rapidly evolving topic, but we've explored the fundamental concepts, the potential benefits and risks, and the crucial role that we all play in shaping the future of generative AI.
We encourage you to continue learning, exploring, and engaging in conversations about this transformative technology. The choices we make now will have a profound impact on the world we create for ourselves and for generations to come.
Thanks for joining us on this journey. Let's keep the conversation going and work together to ensure that generative AI becomes a force for good in the world.